Okay, we can finally get to the goal of all of these videos, which is to get to the P-series test. I could have just told you what the P-series test was, and it's really, really easy and really, really simple. But I want you to see why. So, this is what the P-series test says. Sigma, n equals 1, and remember, this can be anything, as long as it's not 0, because we can't have 0 in the bottom. But n equals 1 to infinity of 1 over n to the p. It will converge if p is greater than 1. For example, 1 over n squared, 1 over n cubed, 1 over n to the 8th. And it will diverge if p is less than or equal to 1. For example, 1 over n to the half, 1 over n to the third, 1 over n, because that would be p equal to 1. And why is this? It's because of the integral test, which says that integrals and their corresponding infinite series, the infinite integral and the corresponding infinite series do the same thing. And we know that this right here is true. Oh my gosh, whoa, that this right here is true. Since the integrals converge / diverge, the series will also converge / diverge. And P-series becomes super useful as we go along, and we are trying to figure out if things converge or diverge. So I am going to write a bunch on the screen here, and I want you to tell me, do they converge or diverge? All right, so there are a bunch here. What's that? 8 of them. Some are P-series, some are other things, some that are P-series converge, and some that are P-series diverge. So I would like you to be careful, make sure that it is a P-series if it's not, but hit pause and try to do all of these and identify if they converge or diverge, and make sure that you say P equals, right? So let me just do the first one. First one is, P equals 3, which is greater than 1, and then I'll use my little therefore sign. It converges. So that's the way I want you to write all these. So hit pause and do the rest of them. Here come the solutions. Okay, we got converge, converge, diverge, 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 although I want to talk about that one in a moment. Diverge, converge, and diverge. So 8 greater than 1, converge. This one, I can pull the 5 out of the series. That's totally legitimate. And it's in this form right here. And you can see that n is a half. So I fall into this form, or this zone. It diverges. This one, same thing. Pull the 3 out front. P is a third, which is less than 1. Therefore, it diverges. This one, if I simplify that, I get root n. And you could technically claim P-series with this, but the better way to do it is to recognize that it fails the nth term test. The limit of this thing is not 0, so it's just impossible for it to converge. And if you go back and think about all of, it was a long time ago, all of this, right? It would have been one of these orange ones right here, right? So it fails the nth term test. The limit of the terms is non-zero. So, let's go down. Where are we? Okay, here. So that one fails the nth term test. This is, when I simplify, I get P is a half, which is less than 1, diverges. Here, simplify, P is 7, which is greater than 1, converges. And then this one right here is similar to this one, and that when I simplify it, I get n to the 2/3, which when I let that go to infinity, does not go to 0, so it fails the nth term test and diverges. Hopefully, you're cool with the P-series and the nth term test, and you see why the P-series is true. That's the whole point of all this. Once you get it, it's good, and it's a quick test for convergence or divergence. And I'll repeat one thing that I said in the very beginning, which is that nth term tells me if something diverges. The integral test and the P-series test, they can conclude whether something converges or whether it diverges. That's going to be the case for most of the rest of these that we go through. So hopefully you're good and you're ready to do some on your own. I will see you soon.